What's up, Algebra 2 students? This is lesson 32. Our objective for today is how do you use the quadratic rule on square roots and how do you use congruent triangles. So first of all, let's talk about the quotient rule for radicals or for square roots. If you have the square root of a fraction, like a over b, that's the same thing as the square root of a over the square root of b. Of course, assuming that b is not negative, or not 0, I mean. So let's see if we can simplify some of these. This, then, would just be the square root of 2 over the square root of 9. Well, the square root of 9 is just 3, so the square root of 2 over 3. So that one would simplify. This one is going to come out to be the square root of 1 over the square root of 5. The square root of 1 is just 1, right? So 1 over the square root of 5. But we can't leave that square root of 5 in the denominator. So we're going to multiply by the square root of 5 over the square root of 5, which will give us the square root of 5 over the square root of 25, which is the square root of 5 over 5. Okay, it's like example 2 and 3. What we're going to do is we're just going to rewrite these as quotients here. So this is going to be 5 square roots of 3 over the square root of 5 minus 2 square roots of 5 over the square root of 3. Now we want to rationalize this so we can not have any radicals there in the bottom. No radical parties in the basement. So multiply this by the square root of 5 over the square root of 5. This one multiplied by the square root of 3 over the square root of 3. This is going to get me 5 square roots of 15 over 5 minus 2 square roots of 15 over 3. Now if I actually want to add these or subtract these, I'm going to have the same denominator. So multiply this one by 3 over 3. Multiply this one by 5 over 5. It's going to give me 15 square roots of 15 over 15 minus 10 square roots of 15 over 15. Alright, so my denominators are the same, so I'm just going to subtract my numerators. 15 square roots of 15 minus 10 square roots of 15 is going to give me 5 square roots of 15 over 15. Then of course we can reduce 5 goes into 5 one time, and it goes into 15 3 times. So this is going to come out to be the square root of 15 over 3. Alright, now when we're talking about numbers, pretty much everything we've worked up, maybe with the exception of geometry, we say that numbers are equal. However, when we talk about shapes or line segments or things, we say they are congruent, which means kind of the same idea as equal, the same, but when we're talking about shapes. So numbers are equal, shapes are congruent. So this line segment is exactly the same as that. If you don't think so, just use your imagination. So the length of this line segment is the same as the length of this. So we'd say their lengths are equal, or AB is equal to CD. So remember, this is how we say the length of line segment AB. This is the length of line segment CD. But if we want to talk about the line segment, this thing right there, that line, we'd say this line is congruent to this line. Okay, so it's kind of the difference between equal and congruent. There's a cool little theorem that says congruent or corresponding parts of congruent triangles are congruent. That's what that means. CPCTC. And pretty much what it means is if you have two triangles that are congruent, then you can use their corresponding parts to solve them. That's what we're going to do now. So this is example 32.5. And it tells us that these two triangles are congruent. They're not exactly drawn the same, but we'll just do that. And we're supposed to solve for x and solve for p. Well, I notice that this side and this side are 6, which means that this side and this side must correspond to each other, and this side must correspond to each other. So because my triangles are congruent, I can say this side length is equal to this side length. So I can say 6x plus 2 is equal to 12x minus 4. Now let's go ahead and solve. Subtract 6x. 2 is equal to 6x minus 4. Add 4. 6x is equal to 6, which means x is going to equal to 1 because I divided by 6. So that is half my answer. X is equal to 1. Now I need to find out what p is. Well, I know what x is, so I can find out what that side is. So let's say 4 times x, which is 1, plus 1 more should equal to p. Well, 4 times 1 is 4, plus 1, so it's going to be 5 is equal to p, or p is equal to 5. So those are my two answers. P is equal to 5, x is equal to 1. Alright, kind of same idea here. This is practice C in your book. These triangles are congruent as well. Those angles are the same. So this side length here corresponds to this side length. This side length here corresponds to this side length. And this side length here corresponds to this side length here. Okay, so it's kind of flipped around from each other, or spun around from each other. But we can still use the same idea, the CPCTC. So let's go ahead and work with this green section first. Again, we're trying to find x and p. If I started with the blues, I'd end up with like 4x minus 1 is equal to p. I'd end up with 2 letters in one equation. So that's why I'm choosing to start with these two green sections. So I'm going to say 4x plus 1 would equal to 12x minus 7. Subtract 4 x's. End up with 1 is equal to 8x minus 7. So if I add 7, I end up with 8 is equal to 8x. So that means x is equal to 1. Okay, I guess that is one of my answers. Now, as we move on to the blue side, I can say 4x minus 1 is equal to p. But I know what x is, so this is going to be 4 times 1 minus 1. It's going to be 4 minus 1 is equal to p. So 3 is equal to p, or p is equal to 3. Okay? Your homework is there on page 147. You're going to do 7 through 17 all, and then 4 more of your choice. Good luck.